My name is Kelly Powell. I'm Technical Manager for Invino Engineering LLC, located in Tampa, Florida. We are an engineering firm working in a specific area of steam and condensate systems. And today I want to talk about deaerator performance testing and operation. Deaerator performance, it really is a critical device to prevent corrosion in the system, either the boiler operation or the steam system. The real question is, do we know if the deaerator is working correctly? And that we'll talk about the testing of the deaerator. The deaerator operation, high quality water is required for the boiler feed system, non-condensable gases eliminated, steam quality for process applications. The deaerator performance is measured in units of parts per billion. So 7 parts per billion is the international standard. So our deaerator, without sulfite being added, should be operating at 7 parts per billion. Now there are 2 types of deaerators. Tray type, agitation is provided by spilling water over stacked trays. Steam is injected into the tray section to bring the temperature up and to let the non-condensable gases come out of solution. The other type is atomizer or spray. Condensate makeup is sprayed through a set of spray nozzles, usually hitting a diffuser, and steam is injected into the process to bring the temperature up and again let the gases come out of solution. Either tray or spray should be able to bring the dissolved oxygen content down to 7 parts per billion. Just a comment on deaerator tray design. Trains assist in the non-condensable gas removal. So up here there are trays here where the water comes and drops across the trays and drops into the bottom of the storage tank, and down below here is feed water. Now the spray type is 2 types, fixed and variable orifice. The makeup and condensate comes in here, sprays out, hits a diffuser system, and the non-condensable gases are removed. Again, both types, gets the dissolved oxygen down to 7 parts per billion. Scrubbing gas steam, 2 actions: preheats the liquid for the boiler operation and increases the water temperature for gas elimination. Non-condensable gas elimination, mechanical separation and diffusion of gas particles surrounding the atmosphere. The thing I really want to talk about is steam venting. All deaerators must vent a percentage of steam. And the reason why is that we have to get the non-condensable gases to come out of solution. We got to get the non-condensable gases out of the deaerator. So out here on top of the deaerator, there should be steam being vented out, which, as you can see in the picture. The thing is that we have to know what is the correct amount of steam that we need to vent to make sure we're moving all the non-condensable gases. Old technology methods for testing the deaerator performance always used to say 14 to 18 inches of a plume. This plume should be 14, 18 inches. Small, and the other thing, a small plume is good, then a larger volume would be outstanding. That would be a significant energy loss then. Energy, and really the venting has no bearing on the true deaerator performance. So we could have a tremendous velocity going out, and it really has no bearing on the deaerator performance. The other method is sulfite residual. We do that chemical test daily, typically, and it tells us that we have, a sulfite residual, but it doesn't tell us that we have removed the non-condensable gases. The deaerator can have sulfite residual but fail the dissolved oxygen test. Therefore, we need to be looking at the deaerator performance. And the thing is that the deaerator, we test it to the ASME standard for testing deaerators, which is PTC 12.3. Sulfite is moved 40 hours prior to testing, so we don't want any sulfite in the deaerator. We want a true performance of the Deaerator without sulfite. Now, we achieve or do not achieve 7 parts per billion or lower. If the Deaerator is running at 7 parts per billion, then we use sulfite to drive the dissolved oxygen close to 0. This test should be done at least every 6 months, and now today plants have online measurements. So it's really a critical test. Conducting dissolved oxygen testing and just the steam venting based on the dissolved oxygen test. The thing is that we know that if we are at 7 parts per billion, or excuse me, 3 parts per billion, we can reduce the amount of venting. We want to hit somewhere around 5 to 7, and then use sulfite to bring it down the rest of the way. If we have a 30 parts per billion test, then we can increase the venting to assist in getting rid of the non-condensable gases or the oxygen out of the Deaerator and get our reading down to 7 parts per billion. The other thing that we can do, we can adjust the steam pressure. So we always say Deaerators should run at 6 psi. Not so. I mean, we can run Deaerators up to 150 psi, but we can adjust up to 10 psi and see what the effects of that is on our dissolved oxygen testing. So there's a number of things that we can do with the Deaerator operation to achieve this 7 parts per billion. And then why we stress this is that 30% of the Deaerators that we find in operation are not meeting specification. The other thing is you must have a proper sampling system. As shown here, we have all the different samples coming down into a central located sample with a sample cooler here, and it allows the plant personnel to take the test easily. The other thing is that all Deaerator internals, spray nozzle springs, trays, internals should be visually inspected. If possible, have the spray action occur. Like this here. This is showing the spray action that we are getting, spray coming out, hitting the diffuser. This Deaerator did not to meet specification. We just didn't get the water to break down into the smallest molecules possible so we could have proper deaeration. The other thing is that there's online oxygen testing, which there are several vendors, and they're very accurate. This one they have 0.1 ppb, and they're very affordable today, and it ensures proper operation of the Deaerator. So. And that's sort of the conclusion. The comments is make sure you're testing the Deaerator at least every 6 months, if not every 3 months. Look at online testing. But it's very critical that we have the Deaerator system in operation. Our approach here is that we do short-term impacts with steam system engineering assessment, steam system balancing, steam system performance, and steam system engineering training, long-term upgrades, process changes, and lowering steam costs. If you have any questions regarding or looking for more technical information, please contact us down here. Here's our email addresses, and we'll be more than happy to help you. Have a great day.